Welcome to all of you. I am Sachin Patil. Now I am delivered lecture on rotational dynamics. It is according to new syllabus. You will get the 16 chapters in 12th science, and rotational dynamics is the first chapter. And here we will going with the recall points like circular motion, center of mass, kinematical equations, real and pseudo forces. First of all, we think about the circular motion. Circular motion. In circular motion, we will get the considerations like that one. Particle moves along circumference of a circle with constant radius and fixed center. Here, first of all, particle moves along the circumference. What is the circumference? Circumference, when we draw the circle with a particular radius r, at that time you will get the circumference. At that time it is the center of the circle and r with the radius of that circle. Then particle moves along the circumference of the circle. This is the circumference, and particle moves along the circumference of the circle. At that time we draw a vector from the center of the circle to the position of particle. This is the position of particle. Then this is called as a radius vector. And particle moves in anti-clockwise or clockwise direction, whatever be the direction of that particle, and therefore this particle moves along the circumference of a circle with constant radius. Because radius is a constant, that means if radius is not constant, at that time you will get the spiral motion like that one with a different radius. Let us consider, here is the center. At that time radius is different here, and so on. And therefore radius of the circular motion is a constant radius and fixed center. That means center is a fixed. If center is not fixed, at that time your circular motion is look like that one. At that time here you will complete the circle. One center is here, you will complete the second center. Some center is here. Second, third circle, you will get the center is here, and that means center is not fixed, it is moving anywhere, and therefore fixed center and constant radius, and particle moves along the circumference, you will get the circular motion. This is circular motion. Right now we are going with the center of mass. Center of mass is nothing but a point of an object where whole mass of the body can be supposed to be concentrated. That means this is the point in the body where all mass of the body can be supposed to be concentrated, and whole mass means you can consider the object with having whole mass where supposed to be concentrated. That means it is one point. When we consider that of the circle or any tire of the vehicle, at that time whole mass of the body can be supposed to be concentrated at the center, and therefore it is the center of mass of that particle or that body. Now we are going with the kinematical equations. First of all, we have to think about the rotational motion. What is the real force and what is the pseudo force? First of all, we think about those things, and then we are going with the real force and Then we are moving with your kinematical equations and so on. So first of all, we have to take the considerations of real force. Real force, it is a force. It is a force which obeys Newton's laws of motion, and it is one of the fundamental force. What is it? What is the fundamental forces? Fundamental forces is nothing but a gravitational force, second one is a electromagnetic force, third one is a strong nuclear force, and fourth is a weak force, weak nuclear force. And those are the force which obeys the Newton's law of motion, and it is one of the fundamental force, like a gravitational force, electromagnetic force, strong nuclear force or weak nuclear force. These are the fundamental forces, and the force which obeys those Newton's law of motion, and it is in between that force, fundamental force, like a gravitational force, electromagnetic force, and strong nuclear force, weak nuclear force. Then it is called as a real force. It is a real force. And those forces which not obey these Newton's laws, and it is another than those fundamental forces, then it is called as a pseudo force. It is not a completely imaginary, because it is a non-real. Pseudo, it is a naming to that one. It is not a completely imaginary, because it is measured by using whatever you can say, instruments. Pseudo force is measured by using instruments, and therefore it is not a completely imaginary force. It is a non-real force, and it follows it does not follow the Newton's law of motions, and it is not in the fundamental one, and therefore it is just called as a pseudo force. Now we are moving with the kinematical equations. There are three kinematical equations in consideration. Those are kinematical equations. First of all, one kinematical equation is V is equal to U plus what can I say, V is equal to U plus 80, or V is equal to U plus 80, where V is a final velocity, U is the initial velocity, A is the acceleration, and T be the time. Then we have to consider like that one, V average velocity, you can say the V is equal to U plus 80, where V is the final velocity, U is the initial velocity, A is the acceleration, and T be the time. Right now, second one is S is equal to, second kinematical equation is S is equal to, S is nothing but distance or displacement. S is equal to ut plus 1/2 at square. Once again, S is a displacement, U is the initial velocity of a particle, T is the time, 1/2 at square, A is the acceleration, and once again T is the time for that particle. And third one is V square is equal to u square plus 2as, where v is the final velocity, u is the initial velocity, a is the acceleration, and s is the displacement of the particle. And those are the three kinematical equations related to that one. Those are the recall points related to your rotational dynamics. In rotational dynamics, first of all, we have to think about the circular motion. What is the circular motion? Circular motion is nothing but a particle moves along the circumference with the constant radius and fixed center. Then point of an object where whole mass of the body can be supposed to be concentrated, it is called as a center of mass. And after that, we have to get the consideration of the pseudo force and real force, which is nothing but a real force which obeys the Newton's law of motion, as well as it follows or it is in between the fundamental forces like a gravitational force, electromagnetic force, strong nuclear force, weak nuclear force, and those are called the real force. Then after that, you have to get the consideration of non-real force, that means a pseudo force which not obeys the Newton's law of gravitation, and it is not in between the fundamental force. It is not an imaginary force, it is a non-real force because it is measured by using instruments. And then we are recalled with the last point is related to kinematical equation, and kinematical equations are three here. V is equal to u plus at, where v is the final velocity, u is the initial velocity, and a is the acceleration, and t with the time. After that, we will get the s is equal to ut plus 1/2 at square. That means s is a S is nothing but a displacement, u is the initial velocity, t is the time, a is the acceleration, t is once again time. Then third one is v square is equal to u square plus 2as, and those are the kinematical equations related to that one. And it is fundamentally required for the rotational dynamics. Those are the recall points related to our rotational dynamics. Right now we are going with the different considerations related to rotational dynamics, and in rotational dynamics you will get the following points related to that one. Here in that consideration, we are differentiate that rotational dynamics in two parts, like it is one related to circular motion and another is related to moment of inertia, that means rotational motion. What is the difference between the rotational motion and circular motion? You can perform the considerations like that one, and we will get the consideration of those circular motion and rotational motion. First of all, what is the difference between the circular motion and rotational motion? Circular motion and rotational motion. Rotational motion. In circular motion, we are going with a simple point. That means you are going with a point, particle as considered as a point, and it is revolve in a circular orbit around the one point or axis. That means axis is outside the body. Let us consider the body is here and it is rotated about that particular center. Then this body does not contain this axis of rotation. That means this axis is outside the particle or outside the body or outside the object. At that time, this motion is called as a circular motion. Let us consider this particle moves along that circumference and center is here. At that time, you will get the circular motion of that particle. For example, Earth moves around Sun. At that time, Sun is work as a center and axis passing through that Sun. Axis passing through Sun. It is not passing through Earth because Earth is moved around the Sun, and Earth moves along the orbit of that orbit of Earth, and therefore Earth is moves along the circumference and center is at the Sun. That means Sun is here and Earth is here. Earth is here. That means Earth moves around the Sun. It is a circular motion. But in a rotational motion, let us consider it is a body, and axis of rotation passed through that body. Axis of rotation passed through that body. Let us consider Sudarshan Chakra in finger of Sri Krishna. At that time you will get this Sudarshan Chakra rotate around the axis, where axis is nothing but a finger of Sri Krishna, and therefore it is a rotational motion of that particular disc or Sudarshan Chakra and at that time this axis is passing through that object. That means in a rotational motion, axis passing through object or body. In circular motion, axis is away from body, not passing through body. Passing through body. For example, motion of Earth around itself. What is it? That means Earth moves around itself. At that time the axis is passing through North Pole and South Pole, and therefore you will get the rotational motion of Earth around the axis passing through itself. And those are the difference between the circular motion and rotational motion. Circular motion having a particle moves along the circumference of a circle, and in rotational motion axis passing through that particular body, and therefore circular motion and rotational motion differentiated like that one. In rotational motion, again we will consider all particles of the body are moving along the axis passing through its body in a circular motion. That means each particle with a different radius, and they are moved along the circumference of that particle. And those are the differences between the here we will consider the particle as a point object and which moves along the circumference. Here it is a distribution of mass or distribution of particle around the axis of rotation, and you will get the different particle moves in a circular motion. Those are the differences. Right now we are going with the characteristics of circular motion. Here are characteristics of circular motion. Circular motion. First characteristic is it is accelerated motion. It is accelerated motion. And second characteristic is it is a periodic motion. What does it mean? Accelerated motion. In accelerated motion, direction of velocity changes at every instant. What does it mean? Direction of velocity changes at every instant. You consider here particle moves along the circumference of a circle. At that time the motion of or velocity of that particle or velocity of Earth is at a different position is different like that one. If if particle moves here, at that time you will get the direction of velocity like that one. If we consider particle is here, then we will get the motion of particle or velocity of particle is here. And if we consider like that one, and different particle is here, at that time the direction of velocity is that one. That means here particle is moving along the circumference of circle. At that time the velocity is along the tangent of the tangent of the circle, which is drawn at the position of a particle and which is along the tangent, and therefore at every point the direction of velocity is changes. And this change shows that direction of velocity changes at every instant, and at that time this motion is called as a accelerated motion. Right now we are going with the consideration of its periodic motion. Periodic motion is what? The particle repeats equal path or same path. Particle repeats its path along same trajectory. Then it is called as periodic motion. That means particle moves along the circumference, and it moves, you will get the consideration like that one. Particle moves start from here and it moves along the circumference and it reaches it here. Again and again it moves along the circumference and reaches it here. Then particle repeats its path along the same trajectory. Then it is called as a periodic motion. Now we are going with the kinematics of the circular motion. Next one is circular motion. Kinematics of the circular motion. In kinematics of circular motion, we have to consider different things which are related to that kinematics. And first of all, we know about the consideration of what are the angular displacement, angular displacement. It is given by theta bar. Angular displacement is nothing but a angle traced by radius vector in given time. Then it is called as angular displacement theta. Then we know about the angular velocity. It is denoted by omega bar, and it is a rate of change of angular displacement with respect to time. Then we know that the angular acceleration, that means alpha bar, it is equal to rate of change of angular velocity with respect to time. Angular displacement theta bar is nothing but an angle traced by radius vector in given time. Angular velocity is nothing but the rate of change of angular displacement with respect to time, and angular acceleration is nothing but a rate of change of angular velocity with respect to time. And it is given by angular displacement is theta, angular velocity is omega, angular acceleration is alpha, which are very similar to or analogous to angular displacement theta bar. It is analogous to linear displacement linear displacement, that means s bar. Then angular velocity, it is omega bar, and it is a rate of change of angular displacement with respect to time. Similarly, it is analogous to linear velocity. It is denoted by v bar, and it is a rate of change of linear displacement with respect to time. Angular acceleration, it is denoted by alpha bar, and it is a rate of change of angular velocity with respect to time. It is analogous to linear acceleration. It is denoted by a bar, and it is a rate of change of linear velocity with respect to time. Now we also know that linear velocity is equal to radius into angular velocity. That means v is equal to omega r or r omega. It is in a magnitude, and in a vector form v bar is equal to omega bar cross r bar. Those are the related characteristics of circular motion and kinetical equations related to that one. Then we are going with one of the most important considerations related to that, angular velocity and angular acceleration, as well as you will get the time period of the circular motion. One of the most important related to that kinematics is the time period of circular motion, and time period of circular motion is nothing but let t be the time period and n be the frequency of circular motion. At the time we considered omega is given as 2 pi divided by t, where n is equal to 1 divided by t, then omega is equal to 2 pi n. Those are the most important kinematics related to circular motion. And now we are going with a uniform circular motion. Uniform circular motion, and a non-uniform circular motion. First of all, we are going with a uniform circular motion. In uniform circular motion, the speed of particle is constant. Speed of particle is constant. Then it is called uniform circular motion. It is a U.C.M. In this case, the linear velocity is always along the tangential path, and acceleration is responsible to the centripetal or radial acceleration, and it is given as always linear velocity is always along the tangent to the circle, and we get acceleration which is responsible for that circular motion, and it is nothing but acceleration responsible for circular motion is called centripetal centripetal or a radial acceleration, centripetal or radial acceleration, and it is acting towards the center, acting towards the center, and it is given like that one: a r bar is equal to minus omega square r bar. Right now, in consideration of that circular motion, let us consider circular motion along the particle, and center is here, radius vector is drawn from here, and right now we are going with the particle moving in anti-clockwise direction, and particle moves in anti-clockwise direction. At that time, the motion or linear velocity is along the tangent of the circle. And this velocity v is moving in this way. Here radius vector is from here, and centripetal acceleration acting towards the center, and this is nothing but ar bar. And therefore ar bar and r bar are both opposite to each other. Ar bar and r bar opposite, and therefore you will get the due to this consideration you will get the negative sign is here. Due to this consideration we will get the negative sign is here, because two opposite vectors are denoted as, let us consider a bar and b bar, two vectors. A bar and b bar are two vectors, are opposite to each other. Then one vector is represented as minus b bar. A bar is equal to minus b bar, and due to this particular property you will get the ar bar and r bar are both opposite to each other, and therefore you plus negative sign is here. It is also given like that one: ar bar is equal to sorry, you are not going with the magnitude of only that ar bar is equal to omega square r, or it is also given as v square divided by r, or it is also given as v omega. Right now we will get the consideration of this uniform circular motion. In uniform circular motion you will get the considerations like that one: linear velocities along the tangent, and radius vector from here to here, and acceleration is moving in that one. Right now we will get the right hand thumb rule, and angular speed of that particular angular speed, it is a direction of angular speed is given by using if it is moving like that one, and it is given by using a right hand thumb rule, and if particle moves in a clockwise direction, at that time you will get the consideration like that one. Omega bar is here. Right hand thumb rule is nothing but, if you consider your right hand and at that time you stretch the thumb and curl fingers are like that one. Curl fingers gives the direction of velocity or direction of particle moving in this direction. At that time the stretched thumb gives the direction of your angular velocity, and like that one here you will get the consideration of, if particle is moving in this way and you can hold the axis in your right hand, at that time your stretched thumb gives the direction of vector, that means omega bar. If it is moving this direction you will put the consideration like that one, and vector of omega bar or omega bar vector is moving in downward direction. Like that one, by using a right hand thumb rule you can calculate the direction of those different angular velocity and so on. So now in a non-uniform circular motion, for example, when we switch on or off the fan, at the time the velocity of fan slowly increases when we on the fan, and velocity of fan or angular velocity of fan slowly increases, and when we off the fan at that time angular velocity slowly decreases. That means first of all we have to go in with the consideration of here what you can say when non-uniform consideration